By definition, we have f of phi is equals to 1. Similarly, we have f of 1 is equals to 1 tilde. One element of power set of x is x and 1 tilde is 6. So by definition of f, here we have f of phi is equals to 1, f of x is equals to 6. That means f satisfy 0 element, f preserves 0 element and f preserve 1 element. So therefore this function f preserves star, it preserve ring sum, it preserve complement, it preserves 0 and 1. Therefore f is homomorphism from power set of x to S6 with related operations. Now next definition is isomorphism. Now any homomorphism is said to be isomorphism from one Boolean algebra to another Boolean algebra if that homomorphism is 1 1 and on 2. We know the definition of 1 1 function and on 2 function. Now whatever function we have taken in earlier case, that is f from Boolean algebra power set of x to S6, its function is a 1 1 function and on 2 function, because we have one element to the each and every element of one element is related to only one element of S6. Therefore this function is on 1 1 function and on 2 function, because for each and every element of S6 there exists at least one element. Here we have exactly one element from power set of x. So this function f is a homomorphism plus isomorphism, right? Now from the definition of isomorphism, we can say that every isomorphism is a homomorphism, but converse is not true. That means it may happen that some homomorphisms are which are not isomorphism. So I'll give you an exercise to find out homomorphism which is not an isomorphism. Now for this, if we have two Boolean algebras as isomorphism, then there is a notation, that is b1 star ring sum dash 0 1 is congruent to b1 meet joint complement 0 tilde to 1 tilde. So this is a notation for isomorphism. Now next definition is an atom. Atom is an element of Boolean algebra which is a cover of 0. Now we know that what is a cover. Cover means there is no element between these two elements. So any element A is said to be a cover atom of Boolean algebra if it is a cover of 0. For example, if we take S6 star ring sum dash 1 6, then 2 and 3, these two are cover of 1, that is 1 is a 0 element of S6, because there does not exist C in S6 such that 1 divides 2 and 1 divides C and C divides 2. Similarly 1 divides C and C divides 3. Therefore 2 and 3 both are the covers of 1, and so 2 and 3 are atoms of S6, because these two elements are cover of 0 element. 0 element is 1, right? So the atom set is S6. Now its notations are that A of x is equals to set of A from B such that A is atom of B and A is less than or equals to that element x. Here x is an element of Boolean algebra B. Now in this S6, if you want to find out A2, then this is the set of all atoms of B such that A is less than or equals to 2. Now here we know that less than or equals to partially ordered relation, that means it is reflexive. So we can say that 2 is less than or equals to 2. So that set will be itself only. Now if we take A of 3, then again we get that as a 3. Now let us find out the atom set of 6 as 6. Now A of 6 means set of all atoms of B such that A is less than or equals to 6. Now here 6 is an upper bound, therefore each and every element is less than or equals to 6. So A6 is nothing but 2 and 3. And atom of 1, that means the atom of 0 element, it is a empty set 5. Now atom of whole S6, or here we can get 6, is set 2 and 3, and atom of 0, that is atom of 1, that is 0 element of S6 is 5. And for that we have two different notations. A of 1 is equals to A, and A of 5 is equals to A of 0 is equals to 5. Here 0 and 1 both are 0 element and 1 element. In our example, 1 is nothing but 6 and 0 is nothing but 1. So here we get A of 6 is equals to A and A of 0 is equals to 5. Now next we have a theorem related to set of all atoms that are if we have any Boolean algebra B starting some dash 0 1, then A of x1 star x2 is equals to A of x1 intersection A of x2 for every elements x1 x2 belongs to B. X1 ring sum x2 is equals to A of x1 union A of x2, x1 x2 belongs to B. A of x dash is nothing but a complement with respect to A, and if we have two elements equal, then their atom sets are equal, and converse is also true. That means if we have two equivalent two equal atom sets, then their two elements should be equal, right? Now let us see the proof of this theorem. First part is that A of x1 star x2 is equals to A of x1 intersection A of x2. Now here we know that A of x1 star x2 is a set, and A of x1 intersection A of x2 is another set. Now to prove that this, we claim A of x1 star x2 is a subset or equals to A of x1 intersection A of x2, and this is our first claim. And second claim is that A of x1 intersection A of x2 is a subset or equals to A of x1 star x2. Now here we want to prove that one set is a subset of another one and another one is a subset of first one. And if we prove these to one, that means that two sets should be equal. That is from set theory of 8th standard. Now let us try for the first one. Take an element from first set, A is less than or equals to x1 star x2. From the definition we have A is atom and A is less than or equals to x1 star x2. From the definition we say that now this implies we have A is atom, that is okay, but here A is less than or equals to x1 star x2. That can be written as A is less than or equals to x1 and A is less than or equals to x2, because we know the result that A star B is less than or equals to A, as well as A star B is less than or equals to B, because star is nothing but a greatest lower bound of set AB. Lower bound is a lower to the set to A and B itself. So here we can say that A is less than or equals to x1 and A is less than or equals to x2. So that statement can be written as A is atom and A is less than or equals to x1 and A is atom and A is less than or equals to x2. So when we combine these two one by the definition of atom, we get A belongs to A of x1 and A belongs to A of x2, and that implies A belongs to A of x1 intersection A of x2. So this means that A of x1 star x2 is a subset or equals to A of x1 intersection A of x2. Right. Now let us take a converse part. For that, assume that A is an element of A of x1 intersection A of x2. A is an element of A of x1 intersection A of x2. That implies we get A is less than or equals to x1 and A is less than or equals to x2 from the two statements, and A is atom. This happened because A is an element of A of x1 intersection A of x2. That means it's an element of both the sets A of x1 as well as A of x2. Now A belongs to A of x1 means A is the atom and A is less than or equals to x1, and A belongs to A of x2 means A is the atom and A is less than or equals to x2. Now here these two conditions says that A is lower bound of the set x1 and x2. A is the lower bound of the set x1 and x2 because A is less than or equals to x1 and A is less than or equals to x2, and A is atom. Right. So this implies we have A is less than or equals to x1 star x2. Right. And this implies A belongs to A of x1 star x2. So here we have second claim proved, and therefore our first part is proved. Now next three exercise can be proved by the same terminology. Now our next theorem is Stone's representation theorem. Now this theorem says that every finite Boolean algebra is isomorphic to the power set of Boolean algebra of set of all atoms. That means, in other words, if we have B star ring some days 0 1 is a finite Boolean algebra and A is a set of all atoms of B, then these two are isomorphic Boolean algebras. Now let us see the proof of that part. We need to define a function f from B to power set of A, where A is a set of all atoms of Boolean algebra B, as a f of x is equals to A of x for each and every x of B. Now to prove that B in power set of A is isomorphic, we need to prove these four conditions. That means f should be 1 1, f is onto, f preserves star ring sum dash, and f preserves 0 and 1. For the first part, let us take two elements, that is 1 1 s f of x is equals to f of y for two elements x y in B. A of x is equals to A of y, and so x is equals to y, because we have the result, that is fourth one, A of x1 is equals to A of x2 if and only if x1 is equals to x2. So that is easy to prove that f is 1 1. Now for 1 to 9 is, let us take any element from power set of A, then C is a subset of A. If C is empty set, then phi is equals to A of 0 is equals to f of 0, and if C is non-empty, then let us take C is equals to x1 x2 xk. Now consider x is equals to x1 ring sum x2 ring sum up to xk, then x is an element of B because B is in Boolean algebra. Now let us calculate f of x. F of x is nothing but A of x. A of x, substitute the value of x, we get A of x1 ring sum x2 ring sum up to xk. That implies A of x1 ring sum f of x2, because we have that result, and if we take union we get C element, therefore f is onto function. Now f preserves star ring sum and dash. Now xy belongs to B, f of x star y is equals to A of x star y, A of x intersection A of y, f of x intersection f of y, therefore f preserves star by the earlier result. Similarly we have f preserve ring sum, and as by using earlier result again we can prove that f preserves complement. Now finally f preserves 0 and 1, that means f of 0 is equals to f of 0 equals to 5, and f of 1 is equals to A of 1 is equals to A. That means f also preserves 0 and 1. So here we have f as a Boolean algebra from B star ring sum dash 0 1 onto a power set of x. Now by using this result we have a characterization for any Boolean algebra, that is our corollary, next corollary, that every Boolean algebra has exactly 2 raised to k elements for some k belongs to n union 0. Now this corollary says that there is no Boolean algebra with elements which is not equals to 2 raised to k. Now its proof is very easy. Let us see that B star ring sum days 0 1 be a finite Boolean algebra and A be a set of all items of B. Now since B is a finite Boolean algebra, A should be finite. Suppose there is in set A. Now by using Stone's representation theorem, we have these two Boolean algebras as isomorphic Boolean algebras. Now there are 2 raised to k elements in a power set of A. Therefore B has exactly 2 raised to k elements. Okay, thank you.
Sandhan, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.